In my last video, I interacted with ChatGPT, an AI that can seemingly answer any question you have to a varying degree of accuracy. Now, despite all of the memes and discussions that we see online, this AI will get better, and probably quite quickly. So today I wanted to ask a question, and that question is, how will this change science YouTube specifically? In the last video, I asked if this would change the day-to-day life for academics. And to me, the answer to this is if the AI is sufficiently improved, it will help the day-to-day Googling process, looking things up, and so on. But another functionality that I've seen here on YouTube and mentioned on Twitter is that this AI can literally write scripts for you. And by script, I mean a script for a YouTube video. So in this video, I'm going to do a mini video of mine. I will tell you about ergodicity in a style somewhat typical of my videos. The catch is my script is written by an AI. It's only enough for about 2 minutes of monologue, after which I will talk about how this might affect science YouTube overall. It's kind of weird to transition into an AI written script, but here we go. Hi there, and welcome to this video on the ergodic hypothesis in statistical mechanics. The ergodic hypothesis is a principle that states that the time average of a system over a long enough period of time is equal to the ensemble average of that system. To understand this principle, let's consider the behavior of a gas. Imagine a container filled with gas particles that are moving around randomly. If we were to track the position of a single gas particle over time, the ergodic hypothesis states that the average position of that particle would be the same as the average position of all the particles in that container. Mathematically, the ergodic hypothesis can be stated as follows. Let X be a system with a set of possible states S, and let f of x be a measurable function that describes a property of that system. The ergodic hypothesis states that the time average of f of x is equal to the ensemble average of f of x, which is given by the following equations. So here we have the time average, and here we have the ensemble average, where t is the total time period over which the average is taken, and p of x is the probability of the system being in state x. The ergodic hypothesis is a useful principle in statistical mechanics because it allows us to use time-averaged measurements to make predictions about the ensemble averaged behavior of a system. This can be a much simpler and more efficient way to study the behavior of a system than trying to analyze all possible states individually. However, it's important to note that the ergodic hypothesis is not always true, and there are some systems for which it does not hold. In these cases, other methods must be used to study the behavior of the system. Thank you for watching this video on the ergodic hypothesis. I hope you found it helpful. Okay, so what did you think of that? For me, so this was a first try interacting with the AI, just prompting it to explain the ergodic hypothesis in the form of a short video with equations. So was it perfect? Definitely not. It could have gone into more detail, but I imagine with some tweaking and asking the AI, I could have gotten a better script. So if we look at the script, just to be as clear as possible, if for some reason you've never seen the ergodic hypothesis, one thing that the AI did not explain is where we get these probability distribution functions, P of X. P of X are the thermal ensembles. They can be the microcanonical ensemble or the canonical ensemble, and there are others. And these ensembles are sort of the regular players in statistical mechanics, And if you're interested in their properties and how to derive them, you can check out my video on the Jane's principle of maximum entropy. The second thing was this line right here. The ergodic hypothesis is a useful principle in statistical mechanics because it allows us to use time average measurements to make predictions about the ensembled average behavior of a system. To me, I think the ergodic hypothesis is useful for the opposite reason. Basically, when you have a system that you're trying to study, it's easier to introduce probability distributions to your calculations than to actually try to study the dynamics. Studying the dynamics is actually a very difficult problem to do. So what we do in statistical mechanics is we instead try to study the system with probability distributions. And what the ergodic hypothesis is telling us is that this is equivalent to studying the average behavior of our system in time. So in reality, the system that we're studying is evolving in time. And what we're doing to study that time evolution is we are instead computing averages over possible states that system can be in. And it turns out that these two averages in time and average over possible configurations, is actually equivalent. And so that's why the principle is useful. But anyways, okay, so with that example out of the way, to me, an interesting question to ask is then, will this change the type of content we potentially see on science YouTube? Now, of course, it won't change completely. There are a ton of really good creators here that wouldn't be tempted to lift an entire script from an AI. But to me, it would be naive to not realize that this is probably a very tempting resource for some people. Science videos are not exactly easy to write. So my scripts that give me a 10-minute video, for example, especially ones that are on the more technical side, take me hours to write sometimes. This AI instead writes them basically instantly. And the problem, of course, with this is that the AI in its current form is the definition of confidently incorrect. It would be easy to mistakenly push misinformation. This will, of course, change as the AI gets better, but perhaps it will just get harder to spot where the scripts are actually incorrect. But to be honest, this problem isn't exactly new. It's a problem that Science YouTube has always had. Research is hard, and it's tempting to lift ideas right now from Wikipedia, for example. It's also tempting to overhype the science that you're trying to convey. So I guess my main conclusion is the following. It's going to be easier to lift easy scripts for videos. These video scripts will be riskier than, for example, adapting a Wikipedia article. But you can, of course, fact check them and correct these scripts that you're given. On one hand, I think this might lead to more good content for audiences looking for accessible science videos. On the other hand, I think we might see an uptick in misinformation. So it's sort of going to be a trade-off. Creators need to do their due diligence when using this service or using this AI. So for me, I don't think I will use this tool either now or in the near future. It's just as much work to fact check this AI and interact with it than it is to write my own script. Assuming the script is something I am a domain expert in or something that is currently important for my research, these scripts aren't exactly hard to write for me. They're also very rewarding to write for me on my own. I just like the process of coming up with a coherent story to teach a topic to people that I'm passionate about. And of course, potentially teach myself a topic in the process. And of course, I learn a lot from the process of writing my script. So I definitely wouldn't want to hand that over to an AI. In conclusion, this might be a great thing for science communication. It also might not be. As the AI gets better and better, there will be less and less downsides to consuming content written by an AI instead of a human. But that's just my opinion. We'll have to wait and see how Science YouTube changes over the next few months and years. No doubt AI like this will reshape this space and many other spaces. We just need to see how and how quickly it does it. But that's all the thoughts I had. So I'm going to end the video here. If you liked the video, feel free to like, subscribe, and leave a comment below.